Hi, this is the YouTube channel for Math Contest Go Go Go. What I want to do for this channel is to build a platform for math lovers in order to make them discuss about different kinds of math problems. I will update a video about challenging problems every day. If you would like, please subscribe below.
Hi, this is the North American Math Contest Go Go Go, and I hope you have subscribed the film if you like it. This week we are going to do AMC 2018 B10. AMC10 2018 B. Yes. So let's go. So, in case you don't know, I'm going to add a brief definition to what AMC10 is. AMC 12 is one of the most credible mathematics competition in the America and possibly in the world. It is also the entrance, to the Math Team America. So, to get to Math Team America, you need three tests in order to get in. The first one is AMC10. If you score top 2.5% on AMC10, top 5% on AMC12, you can directly go to AMY. And if you get well on AMY, you can get to USAMO. And if you perform well, I think possibly it's top 6 in USAMO, you can get a spot for the US Math Team National Team, which you are going to participate in the International Mathematics Olympiad. Okay, so I'm going to speak about format for this for presentation. I'm going to create a rating for each problem, which it means how hard each problem is. And I'm going to include a type, which is like what type this problem belongs. Like, is it belong to trigonometry or analytic geometry? Yes. Let's start our first problem. Problem 1. Kate bakes a 20-inch times 18-inch pan of cornbread. The cornbread is cut into pieces of 2-inch times 2-inch. How many pieces of cornbread does the pan contain? So we know that we are required to find how many 2-inch times 2-inch square is inside the 20-inch times 18-inch. So to do this, we only need to find a solution. So we only need to we'll find the total area of 20 times 18 and divide by the each area. Since 2 is the divisor of 20 and 2 is the divisor of 18. So we are able to get the answer is 90-inch. The 90 pieces, which is A. Overview. This problem is a basic problem and it should be solved easily. And the type should be basic algebra. Yes. I would like to rate this problem 1 out of 5 because everyone should get this problem right. Problem 2. Sam drove 96 miles in 90 minutes. His average speed during the first 30 minutes was 6 mph and his average speed during the second 30 minutes is 65 mph. What is his average speed during the last 30 minutes? So to do this, you only need to calculate the speed of during his first 30 minutes and during his second 30 minutes. You can get the distance about how long he runs for the first 60 minutes, and you can use this to get the distance for the last 30 minutes, which in this way, you only need to divide by 0.5 because 30 minutes is equals to half an hour, and you will get the final answer, which looks like this. So we first get the miles of the first 30 minutes, which is 30 miles. And we get the miles for the second 30 minutes, which is 32.5. And we get the distance for the third 30 minutes, right? And then we know this is the distance, 33.5 miles, is in 30 minutes. So we know that in 1 hour, his speed is going to be 67 miles. Type. Yes. So I give the problem a rating of 1.125. Problem 3. In the expression, each blank is required to fill 1, 2, 3, 4, and each digit is being used once. How many different values can be obtained? So we know that we can choose 6. So you know, like, since we know that A times B is equals to B times A, right? So we only need to choose the first two numbers here without order. And then these two can just be placed automatically, right? So we know that here and here, we choose these numbers, 4 numbers. We choose 2 numbers in 4 numbers, and we have 6 possibilities, and we switch between this and this. So we divide by 2. Therefore, we have 3 possibilities, which answer is B. Hot tip. If there is an answer that is significantly larger than the rest of the one, then for 99.99%, it is definitely going to be wrong. This is a basic combinatoric problem. And actually, you are able to solve this problem even without combinatorics, because you can just list out all possibilities, and there are only 24 times, right? A 3-dimensional surface has dimensions x, y, z, and 3 faces, of which has dimensions x, y, z means has length x, width y, or height z, and 3 face area, which here means area of 24, 48, 72 as area respectively. What is x plus y plus z? So we write out the equation for each of them, right? After that, we are able to find from here, we divide this, and this. So we divide this to this. And we know that the ratio between z and x is going to be 3, which z is going to be 3x. We plug in the z here, which we get x times 3x is 48, and we can get x is going to be equal to 4. Y is 6 and z is 12. Therefore, the answer is 22. Yes. This problem, I would like to give him 1.5 point, because it still requires you think a little bit by substituting. But if you don't substitute, you are still able to get this problem correct. You can just try the problem and you will find the correct answer. Okay, how many sets of 2, 3, 4, 5, 6, 7, 8, 9 includes at least one prime number? So for this problem, we are going to use complementary counting. What is complementary counting? Complementary counting is that it's this formula, the total cases minus the cases we don't want is the cases we want. So we know there are total subset, which is 2 to the power of 8 is 256. Why is it 256? Because you can choose to include each number or not during each case. So for the first one, you have the choice. You can choose 2 or not choose 2. So you have 2 possibilities. And for the second one, you also have 2. And for the third one, you also have 2 possibilities. So you will have 2 to the power of 8 possibilities, which is 256. And the total subset that only include composite. We know that in this set, there are only 4 composite numbers, 4, 6, 8, and 9. So we can just use the same way. We can get 2 to the power of 4 is 16. And we know total is 256. And the number we don't want is 16. Therefore, 240 is the right answer. If you don't use this way, you need to think about 2 cases and it will be much harder, but it's still easier compared to the problem that I will be talk about today after. Another hard point is that some people might not know about use 2 to the power of n to calculate subset. So in all, I'm going to give this problem a difficulty of 2 divided by 5. A box contains 5 chips named 1, 2, 3, 4, 5. Chips are drawn randomly at one time without replacement. Remember, without replacement is very important. Until the sum of the values drawn exceeds 4, what is the possibility that 3 draws are required? Okay. Without replacement means if you get a chip, you don't take it back. So which means for each, you can only use once. So we know that there are only 4 chances to take chips without exceeding 4. I mean, for the first 2 times, there are only 4 chances, 4 possibilities you take, and the values won't exceed 4, which they are respectively this, and this. So we know for each one, there is 1/5 possibility because there are 5 numbers here. To choose the first number, and there are 1/4. Why is it 1/4 instead of 1/5? Because one number is already chosen. So we time which is 1 divided by 5th, time 1 divided by 4th. Then why do we time 4? Because there are 1, 2, 3, 4 chances here. So our answer is going to be 1 divided by 5. This problem is similar to 5. It can also be used as complementary counting. If you get that 4 only types are 1, 3, 1, 2, 3, 1, 2, 1, the problem is going to be much easier. So the difficulty for this problem is 2 divided by 5, which you need to think a little bit. Problem 7. An AOPS person, he writes the answer and he says the solution is a time-consuming and practically useless. An AOPS user writes the solution for this problem and he says the solution is time-consuming and practically useless. And I think it is same to this problem. Okay. In the figure below, incongruent semicircles lie on the diameter of large semicircle, with their diameters covering the diameter of the large semicircle with no overlap. Let A be the combined area of the small semicircles and B be the area of the region inside the large semicircle but outside the semicircle. Oh my god. The ratio of A to B is 1 to 18. Since we know that the ratio is 18, so there are going to be 18 small semicircles, and there's going to be 1 large, and you are done. There's only 19. So this is how the answers. I think this problem is people who make AMC10, they also make AMC8, and they accidentally put one problem on AMC8 into AMC10. I think this problem is easy, too easy. It is even easier than problem 1. Okay. Sarah makes a staircase out of toothpicks as shown. This is a 3-step staircase and uses 18 toothpicks. How many steps would it be in a staircase that uses 180 toothpicks? I'm going to give a solution like this. So we divide each stage. You see, the first stage, we take off the bottom part, and the second stage, we take off the bottom part. And the third stage, we include the previous bottom part, but we omit his bottom part. So we have a final, which final is the last stage's bottom part. So in this case, why am I going to do it? Because it will form an arithmetic sequence, 3, 5, 7, so on, so on, so on. So we know that for each one, it adds 2, right? So we know that each of them is 3 plus 2x, has a format of 3 plus 2x, right? So it takes a 3 out, and we include n as stage, so we know that it is going to be 3n, and n is going to be the final. And now we are going to calculate about the increasing 2 in each stage. Here we use the formula. The first 1 refers to the first 2, first time 2. And n minus 1 refers to the last time 2. N minus 1 refers to the term, the total term it has. Like this, it has 2 terms. Why it has n minus 1 term? Because the first one doesn't count. The first one doesn't have any 2 time x increment. And we divide by 2. Yes. So why is this formula coming? Like, why use this formula? Because like, you know, like when you calculate 1 plus 2 plus 3, I mean the arithmetic sequence is a formula. The first term plus the last term times the total term divides by 2. So I'm applying here to solve it. So after you do a simplification, you are able to get there is n squared plus 3n is 180. And using easy quadratic, you are able to get n is 12. This problem has sequence and quadratic equation. So it will be a bit hard for people who hasn't learned arithmetic sequence, but I think everyone should learn, like, at least learn a bit about arithmetic sequence when they attempt AMC10. Yeah, I think so. Quadratic equation doesn't matter a lot because you are able to use trial and error method to get n squared plus 3n is 180. So the difficulty is 2.2 to 2.25 divided by 5, since this problem requires you to get the formula, deduce the formula. The face of each 7 standard dices are written at 1 to 6. Let P be the possibilities when all 7 dices are rolled. The top faces of each one are 10. What other sum occurs the same as possibility? So we should know a rule here, dice symmetry rule. When the possible number for the dice are a plus 1 to x, which a is the smallest number it can achieve and x is the largest number it can achieve, PA is equal to PX, and it's so on and so forth. So we know that since P7, this 7 is the smallest number it can achieve. 1 plus 1 times 7, and 42 is the largest number, 6 times 7. So we can use this to infer 8, 9, and 10. We know that 10 is going to be equals to 39. In the rectangular parallel pipe shown, AB is equal to this. BC is equal to 1 and CG is equal to 2. Point M is the midpoint of FG. What is the volume of the pyramid with base BCHE and apex M? So we know these two are like congruent. So we should like, what our solution is a bit similar to the complementary counting, which is we take this away, and take that away. Where you don't know what this and that means, EMFB and HMCG. So we know this is 3. 3 times 1 times 2 is 3, right? Now let's talk about these two pyramids. We know the base is 3 times 2 divided by 2 is 3, and the height is 1. 0.5, and this is 1. And we divide 3 things like the pyramid is 1 base times height divided by 3, right? So we know that the total area for these two are 1. So we know that the final answer is going to be 2. 3D geometry, complementary counting. It is like this problem is going to be pretty hard for people who doesn't feel great for like 3D geometry, doesn't have a great 3D geometry skill, Similar to these two problems, using complementary calculation are able to solve this problem easier. It will be somewhat harder if you choose to calculate the pyramid directly. The difficulty is 2.5, requires some thinking. Next problem. Which of the following numbers is never a prime number when p is a prime number? Now we can see we have two solutions. One is trial and error, and the second one is using mod. The first one, we can try each one and we will find there are exceptions. For the first one, it won't work when p is equal to 5. For the second one, it won't work when p is equal to 7. For the third one, it won't work when p is equal to 5. The fourth one won't work when p is equal to 19. So therefore, only p squared plus 26 is right. Let's use this. For this solution, we need to deduce that we need to use multiple of 3 as the weapon to help us get the problem. Since we know they are odd numbers, so multiple of 3 can easily find whether they can be prime number or not. So we find that since we know this rule, remember this rule, p squared divided by 3 always has remainder of 1 when p is prime, excluding 3. So we know that only this one will work. Like, because it has the divisor of 1, and 1 plus 26 is 27, so only this one works. And we know that we plug in 3. 3 squared plus 26 is 35. 35 is composite. So we know that this is never going to be a prime number. Trial and error are different 1 point. It's at here, when you decide this and this, you have to choose many numbers in order to decide whether this is prime or not. So this problem. Line segment AB is a diameter of circle with AB is equal to 24. Point C, not equal to A or B, lies on the circle. As point C moves around the circle, the center of mass of ABC traces out a closed curve missing 2 points. To the nearest positive integer, what is the area of the region bounded by this curve? Centroids of the triangle split medians into 2.1. This is the knowledge that we should remember. So we know that centroid to midpoint, another rule. And we use this, we are able to get 24 divided by 2 is 12, which 12 is the radius. And 12 divided by 3 is going to be 4, which 4 is the midpoint. Yes, the correct one we are going to find. And we use 4 squared pi. The final radius, 4 squared pi is 16 pi, which is approximately equals to 50. This problem focus mainly on the definition of centroid. If you know the definition of centroid very well, you're able to get this problem. How many of the first 2018 numbers in the sequence 101, 1001, 10001, 10001 are divisible by 101? So we should find patterns. We know that 101 divides by 101, it is okay. So we make it a start. 1001 is it will have the remainder of 12, and it will have the sequence of 921. And here it will have the sequence of 910. So we know that these two are not okay, and these two are okay. So we know that there's going to be 1 for every 4 numbers. Okay, so we know there's going to be 1 for every 4 numbers. We know the starting point is 1, and the ending point is 2017. So we know that 2016 divided by 4 plus is equal to 504. Yes. a list of 2018 positive integers has a unique mode, which occurs exactly 10 times. What is the best number of distinct value that can occur in the list? So we know that it is mod exactly 10 times, so it's 10 minus 1 is 9. 2018 divided by 9 is 223. So we want the numbers to have largest values, like have more numbers for each one as much as possible, and we need the last number to be a number to have the mod of 1 and a number to have 10 times. The rest of them have 9 times. Repeat again. There are 223 groups of number that occurs 9 times. One number occurs 1 time, and the rest of the number, which is the last one number, occurs 10 times. So it's 225. This problem is might be, some people might get this answer because he might just misunderstood that these numbers like occurs 10 for many times. So which in this case they are going to divide by 10 and plus 1. This is definitely going to be wrong. So only B is right. Let A1, A2, A3, A20, A10 be a strictly increasing sequence of positive integers such as this. He's asking us what is the remainder when this divides by 6. Recall the Nico-Matches theorem. It states that the cube that added up for all numbers is equals to all number added up square. It will be used to help benefit this problem a lot. Let's see how it will benefit. So we know that this is 2018 and we add the square. So it's 2018 to the power of 2018 to the power of 2. So it's 2018 to the power of 40636, right? So we know that the last digit of this is going to be 2. So which we are able to get the digit for this is going to be 4. It will be very easy if you know the Nico-Matches theorem very well. In rectangle PQRS, PQ is equal to 8 and QR is equal to 6. Points A and B lie on PQ, point C and D lie on QR, point E and F lie on RS, point G and H lie on SP, so that AP is equals to BQ less than 4, and the convex octagon ABCDEFGH is equilateral. The length of the side of this octagon can be expressed as the form k plus m to the root times root n, where k, m, n are integers and n is not divisible by the square of any prime. What is k plus m plus n? These are the solution. So the first step is like, we know that since this is 8, right? This is 6. This is 6. This is 8. So what we are going to do is we can since we know this is equal to this, so we can use in terms of x, we can express this and this, which this is x and this is x minus 1. Based on the Pythagorean theorem, it is easy that we can list out the formula of x squared plus x minus 1 squared is equals to 8 minus 2x squared. And after we expand it, it's 2x squared minus 2x plus 1 is equals to 64 minus 30x plus 4x squared. And we get x can be this, right? So we know that, why don't we use 15 plus 3 times root 11 divided by 2 as the answer? Because it will exceed negative when when you minus it from 8. Okay. So since the problem, it is required us to find k plus m n, and k plus m root n is the length of a side, which is this. So we need to find 8 minus 2x, right? So we know that only this will be positive. If this is plus, then it's going to be negative. So therefore, we finally get the answer is going to be 7. 7 is for, yes. Why is it 21? Because it is 7 plus, it should be this. It should be like 3 plus 11 plus negative 7. Since it is asking us the sum of k and n, it is going to be 7 ultimately. Here's my comment to this. This problem is the start of difficulty. It had a difficulty of 3 stars. Next problem. 3 young brother-sister pairs from different families need to take a trip in a van. These 6 children will occupy the second and third rows in the van, each of which has 3 seats. To avoid disruptions, siblings may not sit right to each other in the same row, and no child may sit directly in the front of his or her sibling. How many seating arrangements are possible for this trip? So we set 2. We set the first pair as AA, the second pair as BB, and third pair as CC. There are 4 cases: ABCBCA, ACBCBA, ABCCB, ACBBAC. So we know that AA can switch because AA are different 2 persons. And BB can switch, CC can switch, so we have 2 to the power of 3. 3 is this can move to this can move to this can move to this, so there are 3 possibilities. 4 is because there are 4 different cases, therefore there are 96 arrangements in a row. $3.5 mark. Next problem. Joe and Chloe and their daughter Zoe have same birthday. Joe is 1 year older than Chloe, and Zoe is exactly 1 year today. Today is the first of the 9 birthdays on which Chloe's age will be an integral multiple of Zoe's age. What will be the sum of 2 digits of Joe's age the next time his age is a multiple of Zoe's age? Nine birthdays means there are 9 values for A to be integer. So we know J is Joe, C is Chloe. So we can make a formula based on the problem. And then we do a minus and plus 1 here. And then we put this here. So we know this is A minus 1. Since there are 9 values for K, there are 9 values for C minus 1. Since we know that the 9 is an odd number, this means this is going to be a perfect square. So we know 36 has 9 solutions. So we know C is 37 and J is 38. 38 plus 36 is 74. 7 plus 4 is 11, therefore the answer is going to be E. The next problem is define a function. This is a recursive function. We know f1 is 1, f2 is 1, fn is equal to this, right? So we are required to find f20 or 18. So you can see we first use basic laws to minus 1 for each of them. You see minus 1, minus 1, minus 1, and minus 1. And then using some arrangement, we make it into this. And then we cross out the fn minus 1 and we get this. We get the rule. So we can know that for each group, we are able to get the rule that f8 minus f2 equals to 6. If you try to attempt, you are able to see fa plus 6 minus fa is 6. So we know there are 336 groups of this. So we know that there's going to be this answer is going to be here. 6 times 336. And we need to add f2. Since we know f2, as the problem has stated, it is 1. Right? So we know the final answer is going to be 2017. There's actually a pattern. The increasing pattern for each one is plus 3, plus 2, 0, negative 1, and 0. Next problem. Mary chooses an even 4-digit number n. She wrote down all the divisors of n in increasing order from left to right. Sometimes he writes 323 as divisor of n. What is the smallest possible divisor? So we are able to see, like, from this problem, we can able to infer some clues. So you see that since they are like have two this, like they must have include this and this. So we know since it must include 323 and 324, and this is larger than 999. So we know that this can also be 17 times 20, which is equal to 17 times 19. So this is acceptable. B have no common divisor. I mean, it doesn't have a common divisor for it, so it is not right. So therefore, we know that C is only the smallest answer here. It requires explicit thinking. Real number x and y are chosen between the interval 0, 1. Which of the following numbers is closer to the possibility that x, y, 1 will form an obtuse angle? So remember the formula, a squared plus b squared is less than c squared. Let this is less than 1, let this is larger than 1. Due to triangular inequality, that two sides must be larger than the third sides. So we can see that we are able to draw a line for this one and a line for that one. And the area that is applicable is the shaded area. So we know the length for this is pi divided by 4, and this is 1 divided by 2. Therefore, it's approximately 0.29. It is the hardest part of this problem is to relate a shape and solve it. Let's see the solution for this one. Recall this statement. The least common multiple AB times greatest the common divisor AB is equal to A times B. So we set this as X and this as Y. So we can replace this as X, Y, 60, 20X plus 12Y. And you put this into that side, and we get it is 0, and you split that apart, and we get it is 0. So we know that since it's 777 can only be divided into two divisors, there are only two solutions for x and y. Finally, the last problem and the boss problem, let x denote. One problem is to write this in the form of x. So you can just put it this minus this divided by this. And you can simplify it into this case. Since we know that this is the number below it, it must be less than 1. The number it reduced must be less than 1. Therefore, we know that if we want this less than 1, we want this less than 10,000. Therefore, this can be negative 100 to positive 100. Let's see, this is another solution. We state this as this signal and an additional part, and we can put it into here and simplify it into this. This is a graph, and in both cases you will get it is less than 100 and larger than negative 100 and less than 100. So both cases it will have a solution of 199. And here we come to the end of this chapter, and I hope you have learned a lot. See you next week. Bye.
In fact, problems They have many solutions, and my solution is only a part of them. If you have more challenging solutions, please comment below. And don't forget, I will also post my problems there. See you tomorrow!